So the cloud has its place. I mean, if I want to find videos that have me in them as opposed to you, that's a good question to ask the cloud. It has the whole history of the world. But if I want to change these pixels into it's Steve rather than it's Robert, that's a crazy thing to ask the cloud.
Hello and welcome to another Coffee with Mr. IoT. My name is Robert Schmidt. I'm Deloitte's Chief IoT Technologist. And today on my show, I have Steve Teig, the CEO of Perceive, a company that makes chips and not just any chips. So with that, I'm actually going to ask Steve. Welcome to the show, Steve. Thank you for being here. Tell us a little bit about you and tell us a little bit about Perceive.
Happy to do that. Well, happy to be here, Robert. Thanks for the opportunity. In terms of me, well, I'm a serial entrepreneur by background. I've started 5 companies before Perceive, which is my 6th, 2 in software, 2 in biotechnology, 1 in semiconductors. And of those 2 went public and the other 3 I sold. So I'm interested in many different things. As for Perceive, Perceive's whole objective is to upgrade the idea of sensing into perceiving. You know, you look at sensors and all they do is hand you pixels or hand you audio, but they have no idea what they're looking at or what they're listening to. And we see a way to fix that, to put so much horsepower right next to every sensor that we can enable every sensor to understand what it's looking at, what it's listening to, what it's sensing, to make products work the way they're supposed to, because they have so much more context about what's going on around them.
So when I did my research on you, I saw one video where you showed this chip that's like 7 millimeter by 7 millimeter. It's like this big, right?
There you go. Exactly. Our chip is tiny.
And people all the who stuff don't understand, 7 millimeter is small. That goes like, I mean, where's that gonna go? And is it already in product today?
So we are already making the chips in production, and our first customers will be announcing their products soon that use our chip inside them. Given that the chip is tiny, it's only 7 millimeters on a side, and that we don't need external memory, we are well suited to pretty much any place that you might reasonably have a sensor. So initially, we're going after home security cameras and doorbell cameras as a first foray into the market, but we can logically be in appliances, in toys, in drones, in phones, in action cameras, and basically wherever you want to do a non-trivial inference inside an edge device.
So I've been fascinated with edge for a long, long time. I sort of like, I started in IoT and then I realized, holy smoke, it was funny, right? People were all about having their stuff at home. I literally had in my house a server. I bought an online server from a company that went out of business. And then I got fascinated by cloud because it's like, I'm not good at running servers. And really there's other people who are better at that. So, but there was this big push to cloud. And now I feel like it's moving to the edge, which is a big step. It's actually enabling it. So tell us that chip you showed us. What can that chip do compared to the other chips we have in there? What's so special about it?
Got it. So there are really 2 points that you talked about cloud versus edge, and also what our chip can do. In terms of the chip, we can do data center class inference inside that little chip at the edge. So the kinds of things people do today in the data centers at the obvious behemoths, doing face recognition, person detection, animal detection, voice recognition, language understanding, the detecting events. A package has been dropped on your porch as opposed to a package has been picked up from your porch. All of that kind of context are things we can do inside an edge device without recourse to the cloud, whereas today, systems that try to do stuff like that all have to send huge volumes of video and audio to somebody else's cloud. So the cloud has its place. I mean, if I want to find videos that have me in them as opposed to you, that's a good question to ask the cloud. It has the whole history of the world. But if I want to change these pixels into it's Steve rather than it's Robert, that's a crazy thing to ask the cloud. It's lower power to do this at the edge because I don't have to send all the data somewhere. It's lower latency because I don't have to wait for the data to get to and from the cloud. It costs less because I don't have to rent space in somebody's cloud for where that data and computation is going to be. And then there's privacy, the creepiness that I don't want video from my house being sent to somebody's cloud where I can't control it. I don't want people to be able to hack my data. And so for sensory type processing, the edge, I think, is a better place if you can do it technically. And that's exactly what Perceive is providing.
So in a way, if I want to simplify this, is you do all the computation in my eye rather than having to go back to my brain.
That's right. And in fact, the biological metaphor is appropriate because nature has made the same choice. Your eyes, your ears, even your fingers do an enormous amount of pre-processing before engaging your brain. And the reason nature does that is because you'd have to eat too many sandwiches to make your brain work quickly enough to support all that whole data stream. So it's to save power that even nature has made this choice.
I have to tell you, the idea that your chip is going to do a better job at who picked up my package and who dropped off a package is badly needed, because the recognition, I love my cam out there, right? It's great. But that one, it sucks at. I don't know what it is about this, but somehow that one, it doesn't do a good job. So I hope yours is going to do great on that.
Thank you.
So I want to switch over to something different. And it's sort of like you started at the beginning saying, so first of all, serial entrepreneurs always fascinate me because the risk you take, I guess, every time, there must be something about you being loving the risk of the challenge. That's one. But two, and maybe you can comment on that. But the second one is you did two software, two bio, and then hardware. How are they ever related to each other?
So first, in terms of the risk in all of that, I think of it as more adventure than risk. You know, when you're on a roller coaster, if you enjoy roller coasters, you want to put your arms up and go, and it's fun. And I find startup companies fun for kind of the same reason, the adventure of working with a bunch of smart people to build something together that we couldn't possibly build separately. I love the idea of building companies as well as building products. In terms of the unifying thread of, if any, among the software, the hardware, and the biotech, two things to say. One is engineering is engineering, whether you're engineering software or a bridge or a chip. The precepts of how it is you engineer things are similar. So they're not as disparate as they appear. But the second thing is, a unifying thread for me has been machine learning. I've been working on machine learning since before people really used that term frequently. And the idea of having automated systems that learn from their environs, that program themselves, that recognize patterns in data that they see, is a consistent thread that applies to the discovery of pharmaceuticals, the placement of components on an integrated circuit, and so on. And so the mathematics, in some ways, underneath the things I've worked on, have aspects of commonality that have allowed me to learn from my biotech experience to apply even to the Perceive work, even though Perceive isn't doing biotech.
Interesting. I often get asked by people, what shall I learn? What classes are really important, particularly young people when they come and they look at your LinkedIn and they go fascinated and then they ask, what do I learn? And I've said to people lately, math.
Absolutely.
And I really think that math has a big comeback right now because of machine learning, because of artificial intelligence. And, I always joked early on when I started my first job that the most complicated math I had to do was percentage calculation. And that was sometimes too complicated for people. Plus minus was about the max I had to use. And I think that's changed today. Tell us a little bit about math. Tell us about machine learning for people who aren't familiar with that. What does that actually even mean? What happens? Where does the machine come in versus what we do?
Right. So machine learning is largely about identifying signals in noise, identifying patterns in complicated settings. So to take a simple example, I show you a photograph and there's all kinds of stuff in this photograph. There's grass and there are trees and stuff. And all I want to know is there a dog in this picture? So with respect to, is there a dog? Everything else in the picture is noise. The grass is noise, the trees are noise, everything that isn't doggish is noise, and the dog is the signal. Well, there is a large body of mathematics, information theory, statistics, and so on, that mathematizes how can you tell whether something is signal versus noise? What does that question even mean? And it turns out you can apply deep mathematical reasoning to the question of identifying signal and noise. And that same mathematics can apply to everything from predicting the stock market to predicting the weather to recognizing a dog in a photograph.
So your chip we talk about photos a lot and we talk about images and video a lot. Is that what it's focused on? Video feeds?
In fact, we can take sensory data of all sorts. So I call out video because that's where the heaviest lifting tends to be, just because video data is so voluminous and comes at you so quickly. So indeed, we can support video imagery. We can support up to 2 cameras at once. In fact, on that tiny chip, but we can support at the same time as the two cameras multiple microphones to do audio, and we can do imaging and audio at the same time. And we have interfaces for the other kinds of sensors you might want to use, be they thermal, magnetic, gyroscopic, radar, or whatever. Most any reasonable sensor can be hooked up to the chip.
Got it. So video is sort of like the topic of the jour, the topic of
Right.
the day, right? Um, what's changed? I mean, we've talked about video a long time. Why is video so topical today? Because we have it all around us, or what do you, I mean, I have my own theory, but I'm curious what you see.
It's a good question. I think certainly we have video all around us and photographs all around us, but also we as beings are so dependent on our eyes. In some ways, we are most dependent in functioning in the environment on imaging information. We just haven't had the horsepower before very recently to do anything about that. As recently as, say, 20 years ago, even 15 years ago, the idea of doing object recognition, of recognizing different kinds of objects in your environment from video was so hard that it was just completely off the table. It was just impossible. So the technology to make that possible is really quite a recent phenomenon.
I worked with a software company that said they started actually in video analysis, right? And they actually went away from it because what they found was that they looked at cars and the images on cars, and the problem they had was with light reflections and so forth. Is that the stuff where you talk about, the horsepower to actually go into that you're going to work towards, that helps us with being smarter machines rather than really learn what that means? Because there's so many details in something like this, right? So I'm curious what you see there.
That's exactly right. I think that the horsepower manifests itself in two different ways. First of all, the sheer volume of video data is enormous. The sensors are quite high resolution, so you're getting an absolute flood of data at a very high rate. So it takes horsepower just to receive it. But the second thing is the point you make about the details, that is being able to be subtle enough and sophisticated enough to ask enough questions about the imagery that you're looking at to find the interesting bits in complicated settings. When I'm trying to recognize a person, but somebody else walks by, there's a bad reflection. It's early evening and the lighting is terrible. There's a light behind him. There are a zillion variants like this, and at least the state of the art today in machine learning is that when these pretty heavy duty programs have pretty heavy duty neural networks, to be able to do that processing reliably. You can do it at all with a tiny neural network, but the accuracy won't be any good. If you want to do a good job today, you need hefty neural networks, and that's exactly what the guys in the data centers are doing, and we're trying to bring that kind of capability into edge devices as well.
So I'm gonna ask you a stupid question, and probably I'm gonna get a stupid response back because it deserves one. But this chip is this small. Today, if I want to do this in a computer, how big does the computer have to be?
People are typically doing this in warehouse-sized data centers. They're running on GPUs, which are a chip this in a package this big, as opposed to one that's this big. So we are a couple
factor
of hundred,
of at least 10, if not 20.
I would say closer to 100, in fact.
That's amazing. That's amazing. So I love this whole sensor thing. What you're basically telling me is you're going to bring processing power and AI way closer to the sensor. You're going to make these sensors smarter and so forth. I love that. I hope actually that we're not going to talk just about video, but we're going to talk about sound sometime soon too, because I feel like sound is sort of like another unexplored area. It's almost like we're going through the senses here, right? We're going from the seeing to the hearing.
Yes.
And I think there's a lot in there too. So that's interesting. But I want to look forward now. And, for someone like you who is a serial entrepreneur, me being an adventurer too, I always sort of like see what's the next thing. And I guess what I'm curious of is not sort of like a prediction of what's the next thing, but what sort of interests you? What do you see the things where you go like, ooh, that one I'm really interested in, or that one, and sort of those areas. Because I have a feeling that's how you go about finding the next thing. It's sort of like, that's a challenge I want to take on. What are those challenges today that we're going to look at for the next 5 years?
Absolutely. So first of all, I want to pick up on the audio thread that you brought up. I totally agree. I think that one of the next frontiers, and we're not the only ones to be saying this, you and I, is language. The quality of language processing in the cloud is actually getting to be reasonable. making that capability available at the edge, where you're not taking audio from your house and sending it to somebody else's cloud, that's something I think we can also enable. So part of what we're working on now is being able to bring not just very restricted languages like commands, but full-fledged language of the sort that you see in gadgets like Alexa and so on, being able to do that at the edge. And in terms of the broader challenge, I guess it bothers me that almost all products are just bad. They're hard to use. Even products that we use all the time, their interfaces are clunky. And the example I always trot out is like your microwave oven. Everybody has a microwave oven and it has 100 buttons and nobody knows how to use those buttons. What's supposed to happen is when I walk up to my microwave and I have broccoli in my hand, the microwave looks at me and says, oh, look at that, it's Steve. And he has a broccoli in his hand. I know how he likes his broccoli. I'm going to set myself accordingly. I should be able to talk to the oven and I say, set this to 375 degrees and keep cooking until the chicken is brown. Why can't I do that? That class of capability without recourse to the cloud, having everything be private inside my own house, this is exactly the capability I think that we're beginning to bring to market. And I plan to spend the next several years using the technology we're building to enable that, to enable products to behave the way they're supposed to.
So I have one little ask in that. Please don't make me ask for 375 degrees because I have no idea how many degrees I should cook anything at. So just please cook it to mild brown. I love that. That was like perfect.
Fair enough.
And it's so funny that you use this, right? I have a fairly enabled house. I talk to my house and everybody laughs at me, but even my wife knows now what to say when. But the one thing we have that I really find is horrible is our fridge has a screen on the front and all we use it for is pictures. And it comes off every day and tells me what I should cook. And these are terrible recommendations. Half of the stuff I don't have in my fridge. It's like, why do you make this up? So I'm so with you. Yes, that'd be fantastic. I'd love it if it gets smart for me and I get my own assistant on that. So thank you for that. It's fantastic. So looking forward to smarter interfaces is, I guess, what I'm hearing you talk about is actually being human in a way. You're almost making artificial intelligence human, where it actually talks to me in the way I want to be talked to, rather than in machine language, sort of.
Yes,
is that exactly what I'm hearing you talk about?
Yes, that's exactly what I think, that the interface should be natural, where instead of it being programming us to say things in just the right way, why can't the machine be less dumb?
It's actually amazing. I mean, even with my accent, voice recognition has been really fantastic. I gotta give it to them. So
yeah, agreed.
That's awesome. So Steve, closing. What do you and I need to do to bring technology closer to people? This is, if you'd ask me what my number one challenge in life is that getting people to adopt more tech or not be so tech adverse or sort of like, embracing tech. I love using tech. I mean, an example for that, there's many examples even now with the COVID crisis where I feel like we could get so much more out of if we'd leverage some of the technology in a better way. What can you and I do to help with that? What's your take on this? What's your advice for me?
I think this comes down to recognizing the problems we're trying to solve. For most people, technology is a means to an end. I mean, I love technology itself also, as you do, but I don't think it's required that everybody love technology for itself. The fact is, technology can help solve so many problems. To your example a second ago, the quality of voice recognition today is excellent. The idea that one can do things that would have been just witchcraft 5 years ago from a voice recognition point of view today, that I can do everything from the trivial, setting a timer via Alexa when I'm cooking something, or something non-trivial. Who was the actress who starred with Cary Grant in this movie? That I can ask Alexa that and get the answer. This is like magic. So I want everybody to experience that magic because it can make your life better.
Fascinating. Steve, anything I didn't ask you that you want to just talk about? Anything I missed? I mean, I could go on like this for a long time. I love meeting people like yourself that are so deep into tech. What haven't we talked about that's on your mind?
I think one thread I didn't manage to pick up that I will mention is the issue of battery power. One of the other places, I think, to make technology pervasive, and it's one we're focusing on ourselves at Perceive also, is you want for wearables, for hearables, for glasses, to have that same horsepower too. Why shouldn't I have that technology available to me wherever, even if I'm walking in a forest? And in order for that to be the case, I not only need horsepower, I need horsepower at extremely low energy consumption. So one of the things that we've been focusing on is being able to run these heavy networks, but to run them in 20 milliwatts as opposed to 2 watts or 200 watts, so that you can have this in a battery powered device and have the technology really be everywhere and not just when you're plugged into the wall.
It's so funny that you'd say that, because I was sitting here and thinking, okay, I got another few minutes to ask Steve a question. If I go on battery, we're gonna talk another 15, because it's so interesting. I'm sitting here. This is a battery-less computer, right? This is a chip that has
Wow.
ARM processor. It has a Bluetooth chip in there and has an antenna, and it takes the power out of the RF energy around us.
Cool.
And so, yes, I think there's actually a lot of energy we can harness around us, right?
I agree.
It's sort of like body temperature, movement. I think we're going to see some fascinating things, in particular with chips like yours that are so small that I mean, we move all the time, right? And, you know, those
Exactly.
sandwiches that I eat, they got to go somewhere, even if they don't go to my brain for transmission. But yeah, so. Well, Steve, I really appreciate your time. It was so great to meet you. Thank you for what you're doing. Thanks for joining the show. And with that, we've come to another end of another coffee chat. If you missed any of today's show, any previous shows, please check out our playlist, Coffee with Mr. IoT. And I say thank you for watching and see you next week.